Okay, so the question is, we've got this tree, and historically, as we've talked about, we used to use opacity maps for this kind of thing in order to make a complex leaf, because that was better than having more geometry. But with current ray tracing technology, be what it is, with rendering, it's way more expensive to have a opacity mapped leaf than it is to have actual geometry and render that. Now, it's RAM intensive to load that geometry in, so we have to be efficient with our leaf. But this old way of like cards with opacity maps is not a great way of working. So let's take a look at how we can go and do a replacement. So here's our tree coming in. We've got our leaves, and then I want to replace it with this guy here. So we're going to do some things with this to make this work a little bit better. We're going to lighten this up and kind of have this as our new leaf. So looking at this, we can see if we take a look at our points, there's a lot of points in this, right? So this isn't ideal. We're at 10,000 points. That's a lot. So we can either modify some of these settings to try to reduce down how much it's using. So by default, this is the this is what it comes in as, right? We've got some kind of stuff that's not good. If you turn on this whole faces, it gets really expensive. So we're going to first resample the shape. We're going to reduce the step size or increase the step size, so we can just kind of keep increasing this, and this is going to make it lower and lower resolution, right, to get to something that's far less than what we have. I'm going to still do some cleanup after this, but this makes it so it's a little more efficient to calculate too. So then I turn on these whole faces, it just pops those right out. So that's a much better output. Still pretty heavy. I'm going to put down a remesh node. And we're going to reduce this to 0.05. Right, so that's starting to look better. I probably don't want even that much. I really just want to get down to like, maybe, 1 per thing here. So now I've got to take this and reduce this even more. So we're going to go ahead and make this like 60. Let's make this 100. Okay. I don't really care that it's, so imperfect. That's totally fine. Right. We've already gotten this down to 235 points. We were at whatever 10,000 points before, so this is an improvement. So we're going to start there. We're going to do a transform, and what I want is I want this point to be at the origin, right, at 0, and I want the leaf pointing down the positive z-axis. Okay, so I can just do this manually, right, where I just grab the handle and start moving this around and visually lining that up. But I want to do this a little more procedurally than that. So first things first, it's here in up and down in the Y, and so this I can just manually. So I'm going to rotate it. So I'm going to say rotate this 90. Okay, that works. So we'll call this init rotation. I'm going to put another transform down because I like to break up my transforms. And now I'm going to take on the Z, and I'm going to subtract the bounding box, and I'm going to say 0 for the input and D underscore Z min, and now you can see that moves it. So not perfect, right? It's caught this point and moved it. So we might have to do some manual kind of, removing of this here. Right now it's on this X. So yeah, so at this point, as much as I wanted to do this, all procedurally, I'm going to do a little bit of manual work here. I could pick that point, but that point's going to change if I change any settings anyway, so that's fine. We're just going to move this something like here. Right, there we go. That's more or less in the right spot. So let's start with that. We can come back and add curve and bend to all of this later. But so now what we need to do is we need to isolate our tree, our leaves. So if we drop down here, we see we've got a leaf group, so we can select that. So we've got this leaf. And now what we want to do is we want to do for each primitive. And there we go. We've got one of our leaf cards there. Ideally, these are all the exact same, but I'm a little nervous looking at that they're not. And I can see already they're not. We have a couple different types. We've got a 4 quad. Oh, I know why. Because we don't want this. We want for each connected piece. Right? Because before what it was doing was taking each polygon, each primitive, and it was looping over that. So now what this is going to do is it's going to give us each leaf card. There we go. So now we've got to figure out which point, because they're all the same, so we're going to figure out which point we want to instance to. So I've turned on point numbers, right? So I can see. I think where this is connecting to the branch looks like it's that point 1, which is super helpful, right? And we have point 4. So what I'm going to do is I'm going to put down a blast. Actually, we're going to do a delete. And I'm going to manually type in what I want to delete, and this is going to be delete non-selected and points, and we're going to say 1 and 4. And so there you go. So they renumbered those, but that's those points, which is great. And I'm going to put down an add. Oh, my hands are on the wrong keys. And we're going to go to polygons by group, and we'll just leave it just like that. So now I've got this line. So if we run this, what we should see is we've got a line that's representative of each leaf, and that does look like it's doing the right things. It appears to be, right? They all seem to be kind of oriented the way I would expect. We'll see quickly if it's not doing the right thing, but this feels like it's going to be right, because it's all the same card, so their point numbers should be the same on each leaf. Okay, so now what I'm going to do is I'm going to put down a resample. What I'm trying to do here is I'm trying to find a way to orient my leaf to these points. Okay, so I'm going to do a blast at this before I resample this. So let's test this. Okay. So blast, we're going to delete non-selected. So points. So there's our point right there. And now I'm going to do a copy to points. Oops. That should be that. That should be this. So there. So there's our point right there. Okay. And it did indeed copy our leaf. But look at our leaf is just pointed in the Z. This doesn't really gain us anything. We need some information. So in this case, I want N. So when I resample this, I don't need to create any new lengths, but I want to create this tangent. And I'm going to tell it to create the tangent as N. So if we look at our normals now, we'll see, or if we look on here, we've got a normal pointing down the length of our line that we've created. Okay, so now I can blast this out, and now I'm going to copy to points. And ideally, that is no longer, there you go, there's our little line right there. Okay, so we can see that our leaf is now following that line from here to here. Okay. Another way that you could do this is you could use a match node. So you could do match size. And what this allows you to do is you're going to come in here and you're going to take this geometry and you're going to match it to like this geo. Right? So there's our leaf, right, is right there. And then it comes in looking like that. With this, this has some, we can do a scale to fit. Okay, we can see we're not lined up yet. We want the axis to be not the scale axis. We want there's a way to capture this. I've done this before. It can get very complicated as you can't capture the transfer, but we're just gonna do this. So we're gonna kind of keep going down this road. So this gives me the ability to then instance that leaf on there, but we can see that we don't have this rotation. So what I want to do is I want to capture this line here, and to be able to create this as our constraint, right, as to the orientation of that. So the next thing I'm going to do is I'm going to do another delete on this, right? So if we look here, we look at our point numbers, and we were taking 1, and I'm going to take 1 to 2. Okay, so 1 and 2 for this one. All right, it's going to do the same thing, give us our 0 and 1. We're going to do an add. We're going to do a resample. Okay, and with this one, I'm going to call this up. Okay, I'm going to do the same blast here, and then I'm going to do a attribute copy. And I'm going to copy on the up attribute. So if we look at this now, if we go into our graph here, we have our normal and we have our up, right, on our point. So now when we place this, there we go. So now that's following our card. Now it needs to be rotated, and that's fine. We can do that really here. So we're just going to take this after our transform, and we're going to put another transform here to make it easy. And we're going to rotate this. It should be on the z-axis. Let's try that. There we go. So I actually wanted to go the other way, so we'll go -90. And there we go. Now we have a leaf matching. Now we haven't captured the size of this yet, so I believe this is where we probably could use our match topology here. So we're going to use the match, not match, we'll use the match node, match size. Okay, we see that it moved it, which we don't really want it to do. We don't want it to translate. We just want it to scale to fit. Yeah, we do need to translate. And for the best fit, we're going to say perimeter. Nope, we're going to say... There we go. So now this is going to kind of match that size. Now we didn't have to do that. We could do this in a less procedural way. We could just put a p scale on here. So we could do an attribute create, and we could tell this to be p scale. Right? And if we just come into this now, we could take our p-scale value and make this 0.5, and there you go. It fits pretty good. So it doesn't really matter. I don't think I want to like use this version just because it's distorting it a little bit. I don't want that. I'm going to just use the p-scale, and we're going to just call this close enough. It's not the exact same size. You know, I could come in here and say, great, then we'll just make it a little bit bigger. And so it spills off the sides a little bit, but this generally feels like about the right size. So there we go. So there's that. So let's come back and let's make this leaf a little prettier. So before this rotation, I'm going to put a bend node. Okay, and the first thing I want to bend is I want to bend it horizontally. So I'm going to take this, and my capture direction is going to be in the X direction here. Okay, and you'll see that it's capturing this way. I can change the length. It doesn't really matter. I'm just going to leave that as it is, but I am going to tell it to deform in both directions. And now, as I bend this, I get a nice little bend to my leaf, right? A little bend there. And now I'm going to do another bend. Okay. And this one, I'm going to bend in the Z, which is what it's currently doing. I'm going to leave all the defaults as they are, and I'm just going to pull down. So now I've got I've got a bend in two directions. That feels pretty natural. The last thing that I could do is I could come in and I could put like a wavy pattern on this. So we're going to do an attribute VOP. And the first thing I'm going to do is I'm going to take my P and I'm going to put down a length node. And then that length I'm going to plug into color so I can kind of visualize. And you can see here as it gets further away from 0, it gets brighter. And I can do a fit range node on that. Right? And from here now I can start taking this and say, great, you know, you see as I pull that in, I get kind of more. So this gives me the ability to kind of adjust, you know, how much I want that to behave. Now I'm going to take a turbulent noise and I'm going to take a displace along normal. So this is going to go into here, and this is going to go into position there. This is going to go into P here. For this, we can plug this into two areas. We're going to plug this into scale, and then we're going to plug this into amount. Now we have this turbulent noise. You can see that it's already breaking up a little bit. I'm going to increase the frequency here so I get more. I can take this amount here and start cranking this up. All right. I'm going to change this to simplex noise. Let's make this 10 and 10 and 10. This might need to be amount, and this might need to be scale. Let's plug this into color to visualize. If it's doing anything yet, it's not. Oh, something's going into V. That's why this goes into. That's why. There we go. Important to have the right thing plugged in. There you go. So you get a nice little value there, a little change. So I'm going to just break that. Okay. Okay, I like that better. Now I can come in here and I can adjust this, how much it's giving, because I just want a little bit. I really don't need a ton. This is just to make it irregular. The nice thing is if you go less frequent, it can feel like each individual leaf is kind of doing something different, right? That starts to feel a little nicer, right? So you can see how kind of that whole thing is moving like that. So then if I wanted to, I could just start playing with some offsets, you know, see if there's a different value that I like that just kind of moves that noise around until I find something I'm happy with, and that's fine there. That does the trick. I like that it doesn't feel so CG perfect. I'm going to pull a little more up here. There we go. I like that. That feels good. That's my leaf. I might bend it a little less, right, on this second bend. If I change the length, you'll get a more dramatic curve, like the capture length as I pull this in. Right, you'll get, you know, a steeper curve. You could also do, there's a way to remap this, I believe. If not, you can just take the capture origin here and start moving that out. It's too far. So as you move this out, it's like make this 0.15 and then shorten this capture length in. Right, you'll have it straight, and the capture will happen in a shorter distance. Right, so this is where the capture is now happening. So you can kind of see based on this little curvature there. So I can kind of set this to be where I want it happening. There we go, something like that. So it's kind of straight at the beginning, and then it dumps out at the end. So, okay, plug this in here. Plug this in here. Take a look. So there's my leaf. It's connecting at the root, and then it kind of does its thing. I could always bend this, you know, do some rotation to adjust this, right? We could come in here and adjust this rotation, not just in the Z that's rotating it this way, but we could also do it in the X, right? If we come in here and, you know, we could back that off if we want to line up with that card a little bit more. So there, now it's pretty lined up and it just kind of has a nice little bend to it. We'll call that good. So now we're going to go ahead and run this on the whole tree. There we go, almost there. And there we go. So now you can see we have replaced the card with our leaf geometry. So those are actual leaves. We can take a look, and it is 4 million points, right? We're looking at almost 5 million primitives, so that's pretty heavy. So I would probably go in and reduce the complexity of that leaf, unless I need it to be really high res because it's really hero. But then if we use a UV quick shade, I'm gonna come back in here so I can get my path to where I grabbed this from. And that's this guy here, so we're gonna use the albedo of that. And there you go. You can see that now I have my leaf on there. Although that UV doesn't look quite right. Let's take a look here. Oh, you know what? It's picking up the UVs from, right? Stand by. Okay, it's as simple as just making sure to add the point texture, so that creates proper UVs. So there's my UVs, those are doing the right thing. So this will regenerate again. So we're gonna just click here. It's gonna go through, recook all these. Okay, so then we're gonna come here and there we go. Now we have proper textures on everything. All right, so we're gonna smooth shade and there we go. So if you have a texture where the color pass that you're using is already pre-multiplied, so there's like black around the color, you may get a black edge on these, and so you'll want to go in, take your color, you'll want to unpre-multiply it by the alpha channel, and then you know, or streak it out to the edges, so it's the color is green all the way out to the edge, and then you're gonna save that out as a new texture. That way you're using the an opacity map to generate your leaves, geometry, and then you have a full color texture that you can pull on that doesn't have any black edging. So now we're just going to merge this back together, right, with our, we'll merge it here so we can actually see with the UV quick shade. We're going to come back up here, and this has the rest of my tree. So there you go. So you can see those leaves are indeed growing. Oh, it looks like I might have. This is a great test here, right? We can see that my leaves are not growing out of the right part. I don't know that all these leaves were actually growing out of this to begin with. Yeah, you can see like my leaves are doing the right thing. My leaf cards just weren't actually connected to the tree, so that's all right. Right, we had some floating leaf cards. I think there were probably some smaller branches in this that have been culled out. But there you go. That's an easy way to do replace some geometry for some leaf cards for actual geo leaves. So hope this helped.